A new version bump has happened to the Linux kernel, which always gets some people excited, even though technically it's just a number. In Linus's own words, version bumps are more about him running out of fingers and toes to count the numbers on, rather than him doing a version bump because of any major developments in the kernel. So that is why Linux is now at version 6.0. But there are a couple of changes that I'm pretty excited about, mainly performance. So there's been some kernel scheduler updates that are going to provide better performance to systems with AMD Zen CPUs, especially the Threadripper and EPYC processors that tend to have a whole lot of cores. This new Nest scheduler aims to keep tasks that you're running on what they call warm cores. So that would be cores in your CPU that were most recently used for some other programs. And this Nest scheduler can improve performance by about 10% up to double, and it can also reduce energy usage. So all around, it should be really good. And we're probably going to see a lot of people trying to patch this in to older kernels as well. People that, for whatever reason, don't necessarily want to upgrade to version 6.0, but of course they're still going to want to try to get those performance increases from that specific patch. There's also another performance boost that was achieved without any downsides because it was just a matter of fixing some code for a 20-year-old chipset workaround that was present in the Linux kernel but was hurting the performance of modern AMD systems. So now things are going to be much more efficient for those AMD systems in our application, at least as long as you're running this kernel on hardware that is newer than the AMD Anthlon era systems, which should pretty much be everybody. AMD also provides last-minute fixes for the RDNA 3 graphics cards in their kernel drivers for Linux 6.0. Kernel 6.0 also lays the groundwork for upcoming hardware like Intel's 4th generation Xeon server chips and their 13th generation Raptor Lake core chips. And going on about changes to CPUs, ARM64 chips received improved meltdown mitigation code, and RISC-V architectures got a lot of improvements as well. And in case you guys aren't aware of RISC-V, it basically extends that openness that we like to see in our source code and our drivers to CPU architectures with an open instruction set so that you don't have to pay some company like Intel or AMD a fortune in order to make modifications or produce your own CPUs based on their instruction sets. So a few small changes are coming with this version bump, but what people are really talking about is a minor version bump that is planned for the near future, probably version 6.0, which is supposed to bring some major changes to the kernel, mainly kernel drivers that are now going to be written in Rust. That's right, it's finally happening. The Linux kernel is getting rusty. There was a lot of talk about implementing kernel drivers in Rust at the Linux Plumbers Conference 2022, which was held in Dublin. And one of the more promising Rust implementations that was shown off was a Rust-based NVMe driver. Currently, the Linux kernel's NVMe drivers are written in C, but if you take a look at these benchmarks, you can see that the performance is pretty much the same with the Rust driver as the C driver, at least on the Western Digital SN840 and the Intel Optane P5800X. I would be interested to see these benchmarks on maybe some of Samsung's NVMe drives as well, since that's what I'm currently running in my rig. And not because of any brand loyalty, by the way. It's just I was able to get my 970 Plus for a pretty good price. Now, unsurprisingly, the transition to start using a different system programming language within the Linux kernel has created a bit of criticism and controversy. One pain, which some end users might be exposed to, at least those that are compiling their own kernels, is having to install the Rust language, mainly the Rust compiler, in order to compile that newer kernel. Now, I can tell you from my experience with using Gentoo that compiling devlang Rust is not a good time. It can take a while, but I will say this, at least within the Gentoo ecosystem, there is a binary available for the Rust language, so you could probably use that if you're running Gentoo specifically. But I can still see how it is annoying having that extra dependency, especially if you're not installing it for anything else. Like if you don't need it for Firefox, maybe you're not using a Firefox-based browser. Maybe you don't program in Rust. So if you're not using those two applications, you might not have the Rust laying on your system. So it might be annoying having that extra dependency, at least until the GCC front end for Rust becomes a little bit more mature. Then maybe you won't need the compiler to compile that Rust code in the kernel. But the biggest criticism about Rust being in the kernel is probably coming from Linus Torvalds himself, who published his response about the subject of undefined behavior for code that is written in Rust. And he wants the Rust folks to realize that A, reality trumps fantasy, and B, kernel needs trump any Rust needs. And the reality is that there are no absolute guarantees ever. The Rust is safe is not some kind of absolute guarantee of code safety, never has been. And anyone that believes that should probably retake their kindergarten year and stop believing in the Easter Bunny and Santa Claus. Yeah, that's Linus Torvalds for you. I'm going to link you guys to this rant in the description because I'm not going to just go through it word for word, but the problem with Rust code in the kernel, at least from what I've been able to understand, is that it essentially boils down to undefined behavior and unexpected behavior within that code. So Rust gets praised for its memory safety and the fact that when you compile safe Rust code, the compiler essentially won't let you make any memory errors in your code. And mind you, those memory errors, like use after free, buffer overflow, and so on, those are responsible for something like 70% of bugs and vulnerabilities in production systems. Okay, just go back and watch any of my videos about major hacks, major exploits that have happened in the past couple of years, and most of them, when you boil down what the issue was, tends to be memory problems. However, it is not okay for the kernel to panic and cause system crashes. Even Linux is, it's kind of a server operating system first. I know that we talk about the Linux desktop a lot, and Linux is even on mobile now with Pine phones, but servers are still the bread and butter for Linux. That's still what most people in enterprise, you think of the people that are donating a lot of money to Linux, they're using it on their servers, and it's very essential that they not crash. And like Linus says in his post, even safe Rust code in user space will do things like panic when things go wrong, for example, overflows, allocation, failures, etc. And he even goes so far as to say that in the kernel, panic and stop, which might be more common with Rust code, that's actually worse than passing the wrong answer like we might see with C code. So it's going to be interesting to see how this unfolds. I know a lot of people have sort of been taking sides, like, ooh, it's based Linus versus the Rust community. I'm not really on any side here because, hell, I'm not a systems programmer. I've never done kernel development, and I don't want to just blindly, follow somebody's opinion. But I think I can see where both sides in this debate are coming from. So the Rust folks, they want to start writing the kernel in a more modern language that's safer, at least in terms of the compiler not letting you create memory errors, and potentially faster. We can look at the benchmarks of Rust versus C and all kinds of different situations, while Linus and the kernel devs that are more fans of C want to maintain the kernel stability and not have the whole system crash from a panic in new code. Hopefully we can somehow get the best of both worlds in a future release. But let me know in the comments below, what do you think about the prospect of kernel drivers written in Rust? Are you excited for it? Are you already using kernel version 6.0 in your systems, and have you noticed much greater performance with them? Like and share this video to hack the algorithm, and have a great rest of your day.